Good morning, dear students. Today we will start the new chapter, which is some applications of trigonometry. This chapter is basically related to trigonometry. In this chapter, it is all about the applications and use of trigonometry. So, some of the things which will be used here, I will tell you. Suppose we have a building, and this is a horizontal level. You can say ground, and here is a viewer which is watching to the top of the building. Then this is his line of sight and this is horizontal level. The angle formed between them is called angle of elevation. If a viewer is watching the top of the building, then this angle is called angle of elevation. And on the other hand, if we have a building or a tower and this is horizontal level and a viewer is sitting here and he is watching the car which is approaching to the foot of the tower. So if he is watching this car, then it is his line of sight and this is the horizontal level because this is parallel to this. So this is also horizontal level. So angle formed between this horizontal level and the line of sight then will be called angle of depression. Okay. So student, let us start exercise 9.1. So our first question is, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Here is a pole on the ground and a circus artist is climbing on a 20-meter long rope. Here is a rope which is connecting the ground level to the top of the pole and it is tightly stretched. The circus, its length is 20 meters and the circus artist has to climb over it. Find the height of the pole. Then we have to find the height of this pole if the angle made by the rope with the ground. Rope is this, so the angle formed by this rope with the horizontal level is 30 degree. It is given this angle to be 30 degree. So let us consider this pole to be AB and the ground level is BC. It is our pole and it is rope. And it is obviously ground level. So we have to find the height of the pole AB. So just think, it is for this angle, this is perpendicular and this is hypotenuse. So we are talking about perpendicular and hypotenuse. So which of the formula, which of the trigonometric ratio we will use here? We should use here. So perpendicular and hypotenuse, we can use sine theta or we can use cosec theta. So in triangle ABC, we will use sine theta. Sine theta, you know, for this angle, sine theta is perpendicular over hypotenuse, perpendicular upon hypotenuse. So perpendicular is AB this time and hypotenuse is AC. So now put the values, you know, sine 30 degree is 1 by 2. AB we don't know, it is required, and AC is 20. Now cross multiply it and we will get AB equal to 10 meters. So what it means, height of the pole is 10 meters. So this way we have to proceed. So you can just pause the video to note down the solution. After this, we will do question number 2. This question is important. A tree breaks due to storm. It is a tree and it breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. It is broken from somewhere. Let us consider from here it is broken and the broken part, and this broken part is not totally detached. It is attached to it, but it is just bending like this and making the angle of 30 degree with the ground level. AB was a tree, and due to storm it is broken from point C, and this part is just bending and making an angle of 30 degree with the ground level. This is the question. And the distance between the foot of the tree. Where is the foot of the tree? This is the foot of the tree, to the point where the top touches the ground. Where the top of the tree touches the ground is D, here. So the distance between them is given 8 meter. We have to find the height of the tree. So AB is tree. We have to find its height. Okay, now listen, because this part only breaks up and bend towards here, so means it's this length will be equal to this length. So let us consider this part is x, so this part is also x. So this part is x, so this part is also x, because this is the same part. Okay, now let us first we have to find BC in this triangle. So in triangle BCD, this is perpendicular from this angle and this is base. So which of the formula we should apply? Tan 30 degree. Tan 30 degree, you know, it is perpendicular upon base. So what is perpendicular? BC on what is base? BD. So you know tan 30 degree is 1 by root 3. BC you don't know, and BD is 8. Now cross multiply, you will get BC equal to 8 upon root 3, because 8 will be multiplied here. Now rationalize it, you will get 8 root 3 upon 3 meter. Okay, now we will find CD, that is x. So for that, again in triangle BCD, this time we needed hypotenuse, and this is base. So which of the formula we will apply? Obviously cos 30 degree, and cos theta is base upon hypotenuse. So cos 30 degree is cos 30, this is base, this is hypotenuse. So cos 30 degree is root 3 by 2. And what is BD? It is 8. And what is CD? It is x. So just cross multiply, you will get x equal to 8 to just 16 upon root 3. When you will rationalize it, you will get 16 root 3 upon 3 meter. Now finally we want to find the value of AB. So for AB, you can just add AC with BC. So AC plus BC, and AC is equal to x, and we know x is 16 root 3 upon 3. So put the corresponding values of AC and then BC. Now add the terms, you will get 24 root 3 upon 3. That is, when you will cancel it, you will get 8 root 3 meter. Okay, so this is the question. You can pause the video and note down the solution. So now question number 3. Question number 3 is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter. There is a contractor and she plans to introduce 2 types of slides. First, for the smaller children, this slide will have the height of 1.5 meter. This is the slide, and its topmost point will be 1.5 meter from the ground level. This is ground level. Okay, it is 1.5 meter and it is inclined at an angle of 30 degree with the ground. So this is the ground level and this slide will make a 30-degree angle with the ground. Inclined means its angle with the ground is 30 degree. Okay, so for the other slide for elder children, the height will be bit more. It will be 3 meter. So let us consider it PQ and let us consider this will be AB and this will be C. So this is the slide for elder children and its inclination will be, and it is inclined at an angle of 60 degree with the ground. Okay, so this way we have to find what should be the length of the slide in each case. We have to find the length of the slide, that is AC and PQ. In this slide, the uppermost point is at 1.5 meter and this is the length of the slide which we have to find, and this slide will make an angle of 30 degree with the ground level. Similarly, for the elder children, the height will be 3 meter and the inclination of the slide is here where the children will slide. So this slide will make a 60 degree angle with the horizon. So we have to find the length of this slide, that is PR and AC. So you know this is perpendicular and this is hypotenuse. So which of the formula you should apply in triangle ABC? Obviously sine theta, and sine theta is perpendicular upon hypotenuse. Sine 30 degree, you know it is 1 by 2, AB is 1.5 and AC you need just cross multiply, you will get AC equal to 3 meter. On the other hand, for triangle PQR, again we will apply the formula for sine, but this time angle is 60 degree. So sine theta is perpendicular, that is PQ upon hypotenuse. Sine 60 is root 3 by 2. PQ is 3 and PR is required. So just solve it, you will get, cross multiplying it, you will get this. So you just rationalize it by multiplying the numerator and denominator by root 3. So you will get 6 upon 3 root 3. So by reducing the terms you will get finally 2 root 3 meter. So here the length of the slide is 3 meter and here the length of the slide is 2 root 3 meter. So you can pause the video to note down the solution. After this we will have 4th question. Question number 4. So question number 4 is the angle of elevation of the top of the tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. The angle of elevation of the top of a tower. We have a tower. Let us consider it to be AB. The angle of elevation of the top of the tower from the point on the ground. And this is the ground level. Somewhere there is a point C, and from this point C, the angle of elevation of the top of the tower is given to be 30 degree. And this is also mentioned, the distance of this point from the foot of the tower is 30 meter. Okay, understood? So what we have to do, we have to find the height of the tower. So you know it is the tower and its height is required. So this is perpendicular basically and this is base. So in this triangle, which of the formula you should apply? Yes, tan theta. So tan theta is perpendicular AB upon base BC. Tan 30 is 1 upon root 3 value of AB is required and value of BC is given, which is 30. So just cross multiply, you will get 30 upon root 3 because 30 will be multiplied here. Now rationalize the terms. You can multiply the numerator and denominator by root 3. You will get 30 root 3 upon 3, that is 10 root 3 meter. So this is the answer. This is the answer. It is very simple question. So note down this. So after this, question number 5. Question number 5 is, a kite is flying at a height of 60 meters above the ground. This is the ground level and here is the kite which is flying. So this kite is flying at a height of 60 meters above the ground. So this kite is flying at a height of 60 meters from the ground. This is the height of the kite from the ground level. The string attached to the kite is temporarily tied to a point on the ground. Now the string, because kite will fly like this, and this is the string attached to the kite and it is temporarily tied at this point of the ground. Let us consider it AB and C is the point where the string is just temporarily tied. The inclination of the string with the ground is 60 degree and the inclination of this string with the ground level is 60 degree. It is 60 degree with the ground. This inclination means always the angle. So this is the string of the kite and it is making a 60 degree angle with the ground level. We can mention here it is the string of the kite. Okay, so what we want to find the length of the string. So we have to find the length of this string, that is AC, where there is no slack in the string. There is no slack in the string string. In that case, we have to find the length of the string. So you can see in this right triangle, this is the perpendicular and this is the hypotenuse. So which of the formula you should apply? You should apply the formula for sine theta. So sine, what is the angle? 60 degrees. So sine theta is the perpendicular, that is AB, upon hypotenuse, that is AC. Now you know sine 60 degrees root 3 by 2. What is the value of AB? 60, and you want to find AC now. Just solve it. It's very simple problem. Just cross multiply. You will get AC equal to 2 can be multiplied here and root 3 can be just go in division. So you can just rationalize, and for rationalization just multiply the numerator and denominator by obviously root 3. So it will be 3 in the denominator and you can use 120. So 120 by 3 will give you 40 root 3. So this is the length of this string of kite. Okay, so this is very simple question. So you just note down this. So thank you so much for today.